the goal of this video is to bring inverses into the mix. We've already seen operations by itself, and we said, well, what happens if we have operations and compositions? Well, now we have this other operation called inverse, and we want to say, well, what happens if I have all three of them? There's maybe operations and compositions and inverses. In what order do I do all of these things? So we're going to start off just by looking at the order. So if you remember PEMDAS, that was always saying, do parentheses, exponents, multiplication, division, addition, subtraction. Those are your operations. That's the second step here. Okay. So what we're going to do is we're saying, before you do any operations, let's take all of the inverses first. So now instead of PEMDAS, we're saying, don't do add, subtract, multiply, divide. Take your inverse first. Okay. After you have everything inverted, okay, you're going to do all of your operations and do all your combining. And the last step here is going to be to perform a composition. Okay. And I have in big bold letters down here one exception to this rule. If parentheses tell you to switch the order of something, you're still going to do that. So just like how usually you don't add and subtract first, but if the add and subtract is in parentheses, you will. The same thing's going to happen. If a set of parentheses tells you, for example, to do a composition first, you should do that composition before you do any inverting or anything else. So let's take a look at an example of one without parentheses and one with parentheses. Okay. So if you take a look at this example, I'm asking you to do f inverse of x, add that to g of x, and then once I have all that done, I'm going to do the composition last. Okay, so let's find out what happens. So before I can add f to g, I need to take the inverse of f. So I'm going to come off to the side here and I'm going to say f inverse of x would be, when I set it up, so remember inverses are switching x and y, so this is now going to look like x equals 2y minus 1. And I need to get this back into y equals form, so I'm going to add add 1 over to the x. Okay, and then I'm going to divide by 2. So I'm going to say y is equal to x plus 1 over 2. Okay, so I would say this right here is the inverse. So instead of writing f inverse, okay, we're going to write x plus 1 over 2, and that needs to be added to g of x, which is x squared minus 5x plus 4. Okay. So remember, if I have something with an over 2, that's a fraction. And so if I'd like to add together a fraction with something that is, in this case, over 1, they would have to have a common denominator. So I'm going to say x plus 1 over 2. I'm going to leave, but this one I need to multiply the top and the bottom by 2 in order to get a common denominator. So instead now this is going to look like x plus 1 over 2 plus 2x squared minus 10x plus 8 all over 2 as well. Now I can add these together. I couldn't add them together when they didn't have common denominators. So f inverse plus g of x is going to look like, all said and done, let's add across the top, it's going to look like 2x squared minus 9x plus 9 all over 2. All right, so instead of this parentheses that I have highlighted in red, I can actually use this expression. And then what I'm asking you to do is to take the h function and plug that in everywhere into the my new function that I just created. Okay, so the idea of composition is whatever is second, which in this case is h of x, I'm going to take that and I'm going to plug it in to what was right before it. Well, what was right before it was this entire big expression. So we did f inverse, got that, then I could add it to g. So all of this is gone now, and in its place I'm going to put this thing. Right, that all goes right there. Okay. And now what this is saying is, here's the expression that I'd like you to plug into. I'd like you to plug h of x in. Okay, so just to make this problem a little bit more manageable, so we don't have to go crazy with all of our squaring. Okay, I'm going to make this a little bit simpler. I'm going to make the squared go away on h of x. We're going to make it look a little simpler. Okay, so what I'm doing here is I'm now going to take 2x squared minus 9x plus, 2x squared minus 9x plus 9 over 2, and I'm going to plug in h of x. This is what this is saying. So I'm going to go here and I'm going to say, running out of space here, so let me move this down. Okay, lost my composition dot. There we go. So now I'm going to go and plug in. I'm going to say this now looks like 2, and I'm plugging h of x in, so instead of x I'm going to write 4x minus 1 squared minus 9, also a 4x minus 1 plus 9. All over 2. Okay, so this is what I need to simplify. So again, let's slide down a little bit. So I need to do a square, and again, I'm going to continue to remind you, squaring is not, okay, just squaring the parts. So I actually need to multiply 4x minus 1 times 4x minus 1. Well, that's going to be 2 times 16x squared minus 8x plus 1. Okay, I can distribute this negative 9 in. That would be minus 36x plus 9. And I have that other plus 9 at the end. Okay, can distribute my 2 in. Oh, this is still all over 2. Okay, and so I'm going to keep going. Got to keep moving down. Distribute. So then now this looks like 32x squared minus 16x plus 2. And then I still have this minus 36x. And I'm going to add these two together. I can make that plus 18. That's a little nicer looking. Okay, all over 2. Okay, and then my last step, it looks like I can put together the negative 16x with the negative 36x. Okay, let's move down again. So I'm going to say 32x squared. Okay, negative 16x minus 36x looks like negative 52x. Okay, and then I have 2 plus 18. Well, that's a 20 all over 2. Okay, and now because these all have a 2 in them, I can actually divide. So let's divide this out and make it look as simple as we can. So this is going to be 16x squared. When I divide 52 by 2, I get a 26. And then I'm going to only add 10 because I divide the 20 by 2. And I would say here is your final answer. If they ask you to do f inverse of x, add that to g of x, and then compose h of x, all of that's done. Here's what you get, this expression right here. Okay, so for the second one, I'm not actually going to go through the entire process. It's very, very similar. The only difference with this one is that we've already done the f inverse of x up here. We don't have to redo that part of it. We can still say that this is going to be x plus 1 over 2. Okay, that's my y there. Okay, and I need to, in this case, because I put parentheses around the composition, plug h into g. Go through all the work with that, and then just whatever the result comes out of plugging f into g, that's what I'm going to add to my f inverse. Okay, so in this case, because of the parentheses exist, it's actually saying, even though we said right here that we want to do compositions last, because there are parentheses around the composition, it's asking us to do that before we do any adding or subtracting or other operations. Okay, so I'll do my inverse, add the result of plugging h of x into g of x. I'll let you try that out on your own, and if you want to see that done, that's something that we can do in class.